and welcome back. We were gone for just a moment, but the show goes on. So we are here with our choice guest of honor here, Anant Patel, Senior Program Manager over at Amazon Lookout for Vision. Anant, thank you for coming down and taking the time to talk to us today about this very exciting service.
Absolutely. Thanks, guys, for having me, and thanks everyone else who's tuning in right now.
Wonderful. Well, this is for folks that tuned into reInvent, this name should sound quite familiar. I believe Lookout for Vision was first announced there. But for those that may have missed it, or maybe just a recap, what is Amazon Lookout for Vision?
Yeah, you're spot on. Lookout for Vision is part of the broader industrial AI services that we launched and are announced at reInvent. Lookout for Vision specifically is around the computer vision space. It's helping customers spot product defects using computer vision to automate quality inspection. And really our goal is to help customers improve their operational efficiencies, reduce their operational costs, and overall deliver a higher quality product to their end consumers. And good news, we actually launched as generally available last Wednesday. So really excited about the momentum, actually going from preview to GA, and looking forward to kind of supporting our customers going forward.
Congratulations on GA. That's a huge deal
Thank you.
and the team. Yeah, we're really excited. Now, when you say quality inspection, can you give us a couple of examples?
Yeah, so I mean, manufacturing industrial is a very large and diverse space. We're talking about products anywhere from medical devices to consumer packaged goods to printed circuit boards. It's really tough to boil down industrial manufacturers. So maybe I'll just give you an example of just an automotive customer that we've talked to. Right, they want to bring in and look at the welding defects. They want to look at their paint defects. They want to look at end-of-line inspection. They want to look at engine assembly. Every single inspection point in that process has their own unique challenges, has their own different defect types that they're trying to solve for, their own defect rates, in fact. And so customers are trying to figure out, how do I actually do this at scale? How do I automate this process? How do I enable my folks to focus on the right types of defects so they don't have to just sit there and watch? And that's really what customers are doing today. There's 2 or 3 main kind of avenues we're hearing from customers of how they're trying to approach this problem. One is around human inspection, very simple, very easy to install. There's obviously challenges with consistency, coverage, being able to scale that. And the other option is really around machine vision. They might be trying to build the types of models in-house, and that often requires data scientists, engineers, and that can be really difficult to build and do again at scale as well. And then the last one is, they're going to third parties, and we know that legacy systems can do really well, but they're often rule-based and they're very constrained to that either that specific use case or that specific environment condition. So it does work really well, but then thinking about how do I maintain this model over time? How do I improve this model over time? That just requires more and more recalibration, and that leads to a lot of dollars for customers. And so those are some of the key insights we've gained, just talking to customers over the last year and a half now. And that's what we're trying to help mitigate with Lookout for Vision. And the bigger issue really with customers is around how do we drive down those costs? We know that warranty claims are a big millions of dollars every year. We know that rework, scrap, customer returns, all those things can lead to millions of dollars of cost over time. So we want to enable customers to work upstream and make sure that they're catching it at the factory floor and preventing it from going down to the customers.
Yeah, I know not all of us have our own manufacturing facility in our in our basement, but I think we are impacted by a lot of the same challenges that you're discussing here around quality control, right? Maybe you order clothes in a certain size and multiple pairs that are all marked as the same size fit differently. Well, then you end up returning some of them, and the manufacturer clearly wishes they'd be able to catch that further upstream because they don't want to be shipping these items that are, let's say, marked incorrectly or defective. And then conversely, in the case where something has even harsher ramifications, a product breaks in operation, could have other downstream consequences. Both the consumer of that product and the producer there have equally aligned interests for trying to limit that as much as possible. Well, I'm talking about pants here and shirts and maybe even machinery breaking, but I'm sure there's a really broad landscape of what constitutes a defect, especially a visual one. So what is Lookout for Vision's set of visual defects that it is targeted towards being able to identify and address?
Yeah, great question. To your point, there are very many defects that we can solve. We try to bucket it into three main types of use cases that we can solve for. One is around surface defects or just product defects overall. So thinking about dents, scratches, holes, anything around shape defects. If it's supposed to be a square, but it's a rectangle, the component is kind of bent or crooked. Those are types of things that from a overall surface defect, that's kind of one major use case that we can help solve for. The second one is around missing components. So going back to a printed circuit board, for example, it's not just one simple object. There's tiny components within that giant circuit board. And they want to make sure that all the components are there. They want to make sure all the components are in the right positions. And those are kind of a second type of defect that we aim to solve for. And the last one is just around uncovering process issues. How do we give customers better insights so that they actually are able to understand upstream processes? Is my machinery need to be maintained? Does it need to be updated? What's causing these defects? And so we have things like a dashboard, which helps you monitor and look at all the different projects that are happening. And you can start to see a trend of, am I seeing a lot of defects in a small amount of time? And how do I use that insight then to better manage my end-to-end kind of operational excellence?
So this sounds great. It's really clear to me the set of problems this solves and sort of the properties that it's looking for in defects. But let's talk about the shape of the product, right? We're talking about making this scalable. Oh, my camera is not cooperating, so we'll wait on that to do its thing. But my audio is still coming through, so the show will go on. So what is the shape of this, right? We're trying to make this scale, make this more automated, reduce costs. I'd imagine this doesn't look like sending someone down with a shirt on that says "Look out for vision" that's going to perform these inspections, right? What does the shape of the product actually look like here?
Yeah. So, I mean, think about the end-to-end customer journey in this way. It is a fully managed service in the sense that you can bring in your data, you can label your data, you can train your model, and you can deploy your model all within the same console. We want this to be a very frictionless experience for customers. More importantly, they don't need any ML or AI expertise to really use this. This could be anyone from a VP of operations all the way down to an operator who can do this. And so first step is collect images, set up a camera, collect images for your production line, bring in those images into the console, label them as normal or anomaly. You can train a model. You can kind of evaluate, does this meet my production KPIs? Is my performance at the right bar that I expect to use this in production? If it's not, you have a couple options. You can add more images. You can also use our feedback loop. And our feedback loop allows you to run new images against the model that you just trained, verify whether it's predicting it accurately or not, and then use that as feedback to improve and train a next version of that model. So that's really kind of the end-to-end experience within the console. But a couple of things that I think are differentiating with Lookout for Vision in particular is that the friction points to come in and adopt is really low. We can train an initial model as little as 30 images. And I think that is really impressive and something we're super excited about and want customers to really recognize, because historically creating a model takes thousands, tens of thousands of images. And I think we're trying to break that perception that you can get started with 30 images, understand and calibrate where that model sits, and then continue to make better decisions based on where that sits in delta to your production KPIs.
30 images, that's incredible, because I think that pretty much puts us in the category of few shot training, right?
That's exactly it. You're spot on. That's kind of the methodology behind it, which actually ended up kind of driving a lot of the science behind this.
And just to put a kind of a contextual spin on this, I mean, the field of computer vision is moving very rapidly. And one of my favorite things that I've seen on the internet is just, how computer vision algorithms fail, how these models fail. Yeah. I think a good number of you have seen this, where there's, I forget the name of the network, but it was trained with like 10,000 images of dogs, and it was just trained to recognize chihuahuas. After giving it 10,000 pictures of chihuahuas, it still was super confused between chihuahuas and blueberry muffins. And this is my favorite thing. I just love it because I mean it's just a cool thing where you're like, oh, is this a picture of a muffin and a chihuahua? Any human being goes, yeah, I can tell in a second, but the algorithm is still confused after 10,000 images. So I mean, tell me more. I'm really curious. Like, what does this performance look like? You know, I'm sure Nick has a lot to say about this because he lives and breathes this world as well. But like this number is fascinating to me. How can you get a high quality model out of 30 images?
Yeah, I mean, so I think there's a couple of things to consider, right? The best way that we can actually make sure that that 30 number at least gives you a good jump start is to make sure that the images are captured in the same general environment, same lighting, same distance to the object itself in question. And that just helps kind of control some of the environmental factors. Yes, there is some robustness in the models to be aware of that and can still work around that, but that's going to be like the best case scenario. We've seen 30 to 40 images train a 95% model. It really just depends on the use case. Going from the top, there's a lot of diverse use cases out there. We know some other ones take more images, and that's okay. But I think we want to be able to bring in 30 images, get that initial model. If it's 70%, 80%, 90%, you kind of see what that delta is, and then use the feedback mechanism that we have on the back end, then to continue to drive that performance up to your requirements. So then your end goal, maybe it's only a few hundred as opposed to 10,000. And so I think that's kind of what we're hoping for. It's not going to be perfect after 30 images, but we know we've seen success and we know that it is certainly possible.
Yeah.
Sorry, I can't. I know the demo is not about this, but I think someday it would be really, really awesome to have to apply lookout for vision on a blueberry muffin assembly line and then try and sneak a chihuahua past it.
I mean, I wish we should have connected earlier and we could have maybe tried that as a demo. We would do a part 2 session and we can see if we can do that one for you.
Thank you.
Yeah, I mean, just like lending a little bit of what I know from Magic Under the Hood, and this is especially interesting and valuable, I think, for the folks that haven't committed to training their models from scratch before. This 30 number doesn't happen magically, in the same way that like durability and availability in cloud infrastructure doesn't happen by accident. There's nothing that stops you from going and taking an open source machine learning algorithm and framework and feeding it only 30 images and seeing what the result is. But I would be remiss if you got a highly effective model with 95 to 99% accuracy with just those raw images. And the reason why 30 images can be so powerful here in something like Lookout for Vision is because it automatically is performing data set augmentation behind the scenes here. So Anand hinted at things like the distance from the camera that you expect it to be inferring against, the lighting, the shadows. Now, obviously, you can control only so much when you record these images, but there is a large set of transformations that can be done in post-processing to those images with software, like changing the brightness, contrast, even just changing the rotation and the angle of it. I know that sounds so trivial, like surely machine learning algorithms can automatically adapt to that, but the algorithm itself may not. But dataset augmentation enables it to understand that from a different orientation. And so by using something like Lookout for Vision, you get all of this data augmentation happening automatically under the covers. And so, I want to make sure we're clear here. You can't just take any machine learning algorithm for object detection, feed it 30 images, and get 95 to 99% accuracy and just have a managed API here. That's not what's happening. There is a whole swath of, work from the Amazon science team that goes into making these models more accurate. And again, a lot of that becomes invisible to users, which is great because you don't have to manage it. But sometimes just understanding what your real alternatives are here makes the value proposition even more compelling. So I know I'm on my machine learning soapbox here. I need like a hat or something for when I'm going to go and just like ramble old man yells at cloud style. But there's my 2 cents. This is some of the stuff that I think makes it most magical, is that if you face this problem, you don't need those thousands of images, not because you don't need them for machine learning, but because Lookout for Vision handles a lot of that work for you in the post-processing space.
Yeah, it's a good call out. I mean, and kudos to the entire team, right? We had a small army kind of work on this over the last year and a half, especially on the science and engineering folks who help make this such an intuitive service to use, as well as kind of the science behind it to make this kind of scale across different use cases. And really that's, I think the power of Lookout for Vision is there's a fundamental kind of science behind it. But it's not just a model that works for only one use case. You can take that same fundamental technology and science and apply it to production line A, production line B, defect A, defect B. and you can still kind of continue to work on quality inspection across different ways. So that's when we think of differentiation points or value prop, as opposed to historical options of, you don't need to create these rules. You don't need to be able to configure this every time. You can kind of be a little more nimble and think about, as I scale my production processes, as I go into new production lines or SKUs overall, I have something in my back pocket that can continue to scale with me. And I think that's kind of what's important with this. Of Lookout for Vision allows customers to really do that over time.
Wonderful. So, I could go on forever about why AI and ML is hard, right? Like I've anyone who's watched or is following the AWS, LinkedIn, or Twitch channels have probably heard me say this a nauseating number of times. But I can only start to imagine how many unique challenges there are for applying computer vision, anomaly detection in the industrial space, and then that's really the set of the ecosystem. It sounds like Lookout for Vision starts to solve for. For folks that sound like they fit into that demographic, what are the biggest challenges here in that sort of life cycle? Again, AI ML is hard, but like let's fill everyone else in who may not be aware, like myself.
Yeah. There's probably 3 or 4 main categories around just adopting computer vision, especially in this space at scale. One, it's really just creating the models, running the models, maintaining the models, and then even a fourth one around just pure integration. So creating the models, like we mentioned earlier, thousands, tens of thousands of images. Historically, we're hoping the 30 images helps you kind of get over that hump. Running the models, Lookup for Vision is nimble in the sense that we don't require any specific hardware or components. We want customers to be able to use their existing camera bases, if possible, to bring in those images and train a model. So we're trying to make that really easy for them. I think the guidance that we typically find is, as long as the image resolution is high enough and clear enough where I can kind of see the defect with the human eye, that's sufficient for Lookout for Vision. And then maintaining, right? We do know cameras get bumped, environmental conditions change, products slightly change, and that can historically skew models. Where there is some robustness in our models right now, we do have the feedback loop, like I mentioned, ultimately to help maintain that performance over time. And then the last one is around integration. And just to be very clear, right? The end-to-end thing is camera acquisition or image acquisition, image analysis, and then integrating that output into something within the physical space. And I think it's really unique. AWS isn't really actively involved in the physical space, at least from a computer vision perspective. So this is the first time we're kind of getting in and really understanding there are, IT OT systems that we need to be integrated with. There are different ways that we need to make sure that we're helping customers. Hey, we found an anomaly. How do I translate that to a better decision? Whether that's kicking off a defective product, whether that's flagging it for a human review, a manual review to make sure that it's truly in fact a defect. All those types of integrations need to happen. We're not the experts in that, but we do have a partner ecosystem. We have about 10 partners across both ends, right? Can help with camera acquisitions, as well as the back-end integration. So collectively, as a whole, I think we can provide that end-to-end solution for customers. But it does take many different components to make sure that we're enabling customers in this space, as particularly manufacturers. How do they move through those change management processes so that they can build the right systems and leverage this at scale?
And the gears are still turning in my head about the different applications of everything you've told us so far. Would something like this work for, let's say, if I'm doing something like a printing press, and I'm printing postcards, and I want to know, you talked about how you and Nick had both talked about how we can build models with such few examples. If I want to make sure that the color is right on the postcards that are coming off the production line, if I want to make sure that they all have a layer of gloss, like, can it do things like that, or are those kinds of things that are you considering edge cases?
No, I think that's within the realm of possibility. I think the kind of the science behind it, right, just a high level, is we train a baseline model for what the customer kind of defines as normal. So in those normal examples that you provide to the data set, if the color is about the same, if the gloss is about the same, we learn that over time. And then when we run inference or try to find an anomaly, we're finding deviations from that baseline. So, certainly if visually, again, if I can see the defect in an image, if I can tell the color's off or a gloss is missing, that's something that we can at least certainly attempt at trying to solve.
Yeah. Well, can you walk us through? We talked about different ways that you apply this, but can you walk us through what is the actual lookout for vision product? As in, maybe you can approach this from the user journey.
Yeah. So, I mean, customers bring in data. They go into the console. They can upload it. We'll obviously go through to the demo, but they can upload. They can label the images themselves. We're talking a few short clicks, really, just to make sure that you have at least the minimum 30. Ideally, more. More data is always better. But you can at least train an initial model. You can get some performance metrics that shows you what's your precision recall, F1, kind of where the model did well, did not do well. And you can kind of get that evaluation. And then as a business owner or an operations or quality owner, you can decide, hey, this is good. I can start to host my model, deploy it in production, and start to run inference on that. Or I can continue to add more images, or I could do the feedback loop until I get to that right point. So it's all in the console. It's all meant to be simplified. We do have integrations with other services. So S3, SageMaker, Ground Truth. So if customers are familiar with those services, they've already labeled data, from previous projects, they can bring in that data. So we're trying not to recreate work at the end of the day.
Yeah. So really just, again, sort of to reiterate, 3 phases to machine learning, and those seem to have direct overlaps here. You have the first set, which is being able to ingest the data and train the model. Then we have deploying, which seems to be just one click, and then you get, as a result of that, an endpoint that you can query with new test images to get the result of the inference. And then you have, so that's really the main 2 phases. And then the third is sort of the update loop of recollecting new data, maybe relabeling it, and then starting back at the beginning where you then retrain the model in hopes of getting higher accuracy or to adapt to new edge cases or training entirely new stations like you determined. So kind of 3 main phases. And as you said, kind of all available through the console there. Again, sort of in this inference, these images come in from on-premises cameras or visual devices, video streams. And when we're thinking about that, something comes to mind for me, at least from reInvent, and that was the Panorama appliance, which, for many reasons, but specifically noted by Andy, due to either power or intermittent internet connectivity, the ability to then have processing happen on site can be very powerful. And in some cases, due to mandatory or regulatory concerns, could be mandatory. So what this sounds like to me, and as my camera goes out again, is there going to be plans in the future or any sort of tie-in? Because it seems like there's some natural synergy here for the ability to then call those inferences to a lookout for vision endpoint that could be deployed to something like a Panorama device.
Yeah, that's a great question. So just to set the expectations, it is a cloud-based service today, but the signal we're hearing from customers is that we want to be able to do inference at the edge for all the reasons you just mentioned. Panorama was announced at reInvent. It is part of the broader industrial AI suite that we've announced, and so naturally behind the scenes, we know that this is a high priority for customers. We're definitely evaluating how do we build those integration points, how do we enable lookout for vision models at the edge, and we'll continue to evaluate that hopefully in the coming months and years.
Wonderful. If my camera hopefully comes back here. Aha, here we go. So, okay, this is great. We've talked a lot about all the phases, but anytime someone tells me we've got a slick console experience, it's going to make your life very easy. That sounds great on paper and conversationally, but I'm going to ask you to show it. Does that sound okay?
Let's do it. Yep. Happy to walk you guys through an example.
Awesome. So whenever you're ready, just share your screen.
All right. Can you guys see my screen?
Yep, you're good.
Perfect. So I'm going to start at the management console. You can search for Amazon Lookout for Vision. We are now listed there, like I mentioned, generally available now. So that is exciting. This is our homepage. It tells you a little bit more about the customer experience, some information about our free tier, which we'll call out later as if you want to get started and even run some initial training models. And there's some helpful resources down here as well. So this is our getting started. Clicking on the dashboard is kind of that third use case I was talking about earlier about uncovering process issues. The dashboard is meant to kind of be the all-encompassing multiple projects, multiple models being run. How do I get from a business owner perspective or a quality manager perspective? What is the lay of the land across all my different projects? And this will help you see how many anomalies are detected, when they're detected, what the ratio is. So we don't have any examples here, but this would just kind of be the end state in terms of just managing your projects. And the best way to think about this again is, production line A, production line B, use case A, use case B, however you want to splice and dice this. Having those unique kind of projects in order to manage your data sets and your models is the best way to do that. So when customers are coming in for the first time, the first thing they want to do is create a project. The project detail, like I mentioned, it can be listed as anything. We're going to go through an example around circuit boards. So I can create a project called circuit board 4.
And I know I'm jumping in, but a project entity here is really like, imagine a single sort of model or checkpoint or station in an assembly line. So everything we're doing here is in the sort of scope of like being able to detect anomalies for a single type of object here, right?
Correct. Yeah. The best way to think about it is if it's a specific product or production line where it's kind of the same object coming out of that line over and over again, like it's a good candidate for a project. You can kind of carve out a unique scope of what you're trying to solve for that particular product. And that's the best way to think about it. Underneath each project is its own individual data set, which is tied to that project. And then all the models that you're training, all the trial detections or feedback loops that you're doing as well. So there's a kind of a hierarchy here. Project is the top layer, and then everything else kind of comes on after that.
Awesome.
Great. So here's a quick overview, right? Pretty quick start, 3 to 4 steps to bring in the data, train it, or label your data, train it, and then deploy it. But the first step you're going to do is create a data set. And by creating a data set, customers have 2 options, and it really depends about how advanced you are. One is you can create a single data set of both training and test images. What we'll do is we'll actually auto split some of the images to a test data set behind the scenes. So it's hopefully easy for you just to bring in a single data set. But we know there's customers who want to have an explicit training and test data set to make sure that they have a higher performance on those specific test images that they want to solve for. So we do offer a couple different options here. For the demo purposes, I'll stick with a single data set. Now, actually bringing in images, we want to offer 2 or 3 different ways that we recommend. One is if you have images on a local drive or a local desktop, you can bring those in pretty easily. Like I mentioned before, if you have images labeled through SageMaker Ground Truth, you can reference that manifest file, and the manifest file will pull in those images and the associated labels with it as well. But the one we see the most often, and the one we probably recommend the most, is actually importing images from S3. What you can do is actually bring in an S3 link to a folder. And also you can do this thing called automatic labeling. And it's a really cool feature that I think will help reduce the friction around labeling. I think one of the pain points of computer vision is not only do I need to collect thousands of images, but I also need to label them. And we're trying to help mitigate that with something called automatic labeler. So if I go to S3 and I have a trained data set here, what I can do, it's a little bit of work on the customer side up front, but it actually saves a lot of time on the back end. If I go through and I organize my images by normal and anomaly, so you see 20 images in normal here, and I have 20 images in anomaly here. What I can do is actually just take the S3 path for this file, copy it in here, can go back. And what I do is enable automatic labeling. And so what this will do is it'll read in the S3 path these 2 subfolders and any of the images underneath it, and it will import those images with the associated labels already into the data set. So this saves a lot of time in terms of being able to, or having to actually label each individual image. Think about this, if this was not 40 images, but even 1,000 images or even 100 images, having to go through and do that manually will take a lot of time from a customer perspective. So we're trying to help them with that process. So you'll see, yep, go ahead.
I'm going to jump in and because like I am the curmudgeon who has had to do that process before. And when folks hear like labeling images, they're probably wondering, what does that mean? And I think like from a human perspective, functionally, it means I have all of these images, let's say from my assembly line, and I visually inspect them, and I have a number of people on my team inspect them, and we'll bucket them into those folders just like you had there, right? We'll say, hey, these are the ones that we spotted defects in. These are the ones that don't have defects. But for a machine learning algorithm, that's oftentimes not enough, right? What the actual semantics of labeling images means for machine learning algorithms is that you will have this massive config file, or like a YAML file in some scenarios, and you will have to have designations of classes with the route to every single one of the images for all of the classes that you would have. So it's not just enough to sort them into folders most of the time. You have to then craft a config file that has the routes to each one of these. So if that sounds painful to you, it certainly has been painful for me. This sort of just looks at the customer experience and abstracts one layer above that and says, no, this is what you would do naturally with your images. So why make you do any more work? So to contrast sort of why that is painful, again, to the point, it could be thousands of images. You want to really make sure and validate that you have thousands of properly scoped images, especially maybe you distribute this to a bunch of people and then the images are coming back from them. Like it's just very painful. So one click, images are in S3. You can just bulk upload them directly from however you've labeled them and have that available. So
yeah,
great.
we're super excited about it, right? And you can see on the screen, you've already labeled enough images because it pulled in those images into normal anomaly. It's already labeled them, and I can actually just click train model. I mean, that's one click to create the data set and the associated labels, and then one click to train the model, and it's that quick. So we're really excited about that one. I do want to showcase a few of the other functionality though, right? If for some reason one of these images was wrong, it's pretty simple to go in and adjust these labels, right? I can go and click in one by one. I can select all and classify accordingly, and those will all change for all the images on the screen. So we do want to make it easy if changes need to be made. But our goal or our hope is that using that automated labeler, customers can bring in the data and then start to train the model pretty quickly. I won't actually go through training the model. I'll just jump to another screen that's already has a trained version. I'm anticipating the question of how long does it take to train. We've seen under 2 hours is pretty much the average. It'll depend on the composition of the data set and the size of the data set, but that's pretty straightforward or expected when it comes to a training time. So jumping over to another model or the initial model. So assume I've now gone through this. Let me jump back really quickly. This is the model subpage. This will track all the different models that you've trained over time. So model 1, model 2, as you continue to add more images, as you do feedback, this can all be tracked. You can see the key stats around how it's performing. And that allows you then to make better decisions on which models I actually want to deploy in production. But what you'll see is 40 images here. We saw really good precision, so recall, and directionally good F1 overall. And this is kind of helps you understand how well is it predicting the anomalies and overall how's the model performing. When you look down and you see how the models, the individual breakdown of these stats, you can kind of see based on low confidence, high confidence scores, which ones were predicted as normal or anomaly. You can sort and understand where does it look like it's performing really well, where it doesn't. As a user now, right, I can make a decision of how do I continue to improve this model? How do I host this model and use it in production? If I want to use this model as it stands today, I can click use model and I get a bunch of CLI commands. And what we're trying to enable here really quickly is you can copy the commands here to start hosting this model. You can copy the commands to detect anomalies and you start running images through the detect anomalies API. And then you can stop hosting the model at the end of the day. So there's really simple ways to do this. We're not trying to recreate additional coding or effort from a customer perspective. We want to enable all the tools directly here on the console for customers to use this.
Can I just, if you go back to the CLI commands?
Yeah.
The second CLI command right there, detect anomalies. So I can just pop this into my command line and specify the path to a local image that I have, and it'll just give me the command line output of what Lookout thinks about this particular image.
Yep, that's correct. You can either pass it as a PNG or JPEG or even an image bytes, and the result right now is an image level classification. So we'll tell you whether it's normal or anomalous with the confidence score. So that can be done then for any of the images that you want to ultimately process for inference.
That's awesome. I mean, that really opens the door, right? Because with that, we can integrate that with just about any other tool, whether it be something that the customer has built in-house, or maybe we can plug it into something like EventBridge. We can do all sorts of cool stuff now.
Yeah, there's a lot of cool stuff that we're considering. We can talk about AWS CloudWatch, for example, where it can start to detect metrics or alerts based on how many anomalies are detected. Creating logic based on the confidence score. We talk about integrations of kicking off defective products, right? If it's anomalous, to kick it off. It's a certain confidence score, maybe push it to a different line for human review. So there's a ton of different logic that we can continue to build based off just even this initial kind of detect anomalies output.
Yeah,
I love the. Oh, sorry. Go ahead.
I was just gonna say, you've now hinted at this a bunch of times, but I'll just say it. Like, anyone who's looking to implement something like this has a sort of threshold where they're gonna want, below a certain confidence level, regardless of the output, they want a human to review that. This is the clear synergy with Amazon A2I, Amazon Augmented AI. And the undifferentiated problem that A2I solves, and we've spoken about it on the show before, because anytime you're making predictions or ML inferences, it comes into play. It is that when your model is above a certain confidence value that you trust, you will, maybe perform an operation or perform business logic automatically based on that result. But if the confidence value is below a certain threshold, you may want to take this small subset of your overall inferences and send those to a human reviewer. And this is why this false dichotomy of, well, you either go all ML or all human reviewer is a bit false. Folks could always implement the system like this, but it was, required a lot of undifferentiated heavy lifting when A2I came around. So now you can have A2I call this this endpoint or this perform this inference for you, and then it'll conditionally route that request, either execute an arbitrary set of business logic in a Lambda function, for example, if it's 80+% or whatever your threshold is, and otherwise send it to a human reviewer. And you kind of get the best of both worlds. You get the speed and the scaling of automation, while still reserving the ability to get those manually combed over results from a human with a threshold that you get to set. And so you can look at these results, you can see what that confidence threshold looks like that you are very happy with, to then route that request. I know you've hinted at the use case a bunch of times, but just to really let people know, it's not as far away and doesn't require as much building as you might expect. There's a purpose-built service on AWS exactly for this, and it's Amazon Augmented AI.
Yep, great call out.
I'm about to start rambling, but so before I did that, I wanted to see Anand. Was there anything else you wanted to show us here?
No. I think, so Avenue 1 was use your model and ready. This sounds good to me. This model looks great. Avenue 2, right, is how do I continue to improve this model? And there's a couple different options. One is quite simply just continue to add more images as you collect them over time, train a new data set or train a new model on that new data set and see what the results look like. That can be helpful. Directionally, it usually is, but it's not guaranteed. I think a more meaningful way to actually get real feedback on how the model is performing is to do something called run trial detection. This is the feedback loop I keep talking about. And really what we want customers to do is bring in a new batch of images that the model's never seen. Let us run predictions on what we think is normal or anomalous, and then verify. Did we do that right? Is that in fact an anomaly, or did we do that wrong? And then add those verified images back into the data set with the correct labels, more importantly, and then retrain a model so that it's learning over time and it's be able to continue to maintain and improve on that performance leading up to, again, your right production KPIs that I keep talking about. So this follows generally the same process in terms of pick one of the models that you've trained that you want to run the trial detection on, import the images that you want to, put in a path here. I'll jump to an example that's already done. And so these are just 20 images the model's never seen. What you can see is that we've made predictions on what's normal, what's anomaly, and some of these are actually already been verified. The ones we want to focus on usually are the unverified ones. So thinking about how do these predictions actually look? Do I agree with them? Do I not? We have a bit of a cheat sheet that shows what are these images actually versus their results. But for just demonstrative purposes, let's just go through and verify a few images. So this one was predicted as normal. It in fact is a normal one, so that's correct. Let's hypothetically say that this one was an anomaly and that was verified incorrectly. So we got two images here that I now have been verified, and I want to add back to my training data set. So if I add those verified images back to my data set, what's happening is those two images that were selected there are now being added to the trained data set with the correct labels. And you'll see in a bit here, the data set will flag that I've actually added 2 images. And if we go back into that data set, you'll get a flag here. Like I said, 2 verified images moved to the data set. You can now train a model accordingly. So before there was actually 41 images in here, and now there's 43. And the associated numbers and their correct labels have now been updated to reflect that as well. So at this point, I've trained an initial model. I've done a trial detection where my model has incorrectly or perhaps correctly predicted anomalies. And I've added those verified images back to my data set to help the model learn over time. And what I can do now is click train model, and I have version 2 of my model ready to go, hopefully train within a few hours. And I have a models page that can help me assess, did the model performance improve? Directionally, we hope that. It's not guaranteed by any means, but over time, like I keep saying, we're gonna hope to get to that production KPI.
This is incredible. I'm at a loss of words. This is one of the most compelling end-to-end machine learning applications I've ever seen. And what I love about this is that, it's funny, like Nick and I have seen so many variations of demos that span the console and the SDK and the CLI. And, I think we've seen enough of these where we both believe that the console experience is important, right? There will always be a time and place for SDK and CLI integrations, always. But the fact that you have a workflow here that really kind of took a layman like myself end to end through what it looks like to integrate this thing, to get it up and running, and then to improve it over time. The thing that really jumps out to me is how simple all this stuff is, because, as we talked about, there's actually a considerable amount of complexity here. And the fact that it is still so simple as a user experience is just really, I'm so impressed. Like, this is simplicity. I like to say, like, simplicity is just never an accident, right? It has to be designed for. And I really admire how much simplicity and elegance you have here. Just even, you were able to just kind of walk, not only as you were talking, but walk us through what it's like to have a side-by-side model and then just take a look at the precision numbers and then flip between them. That's awesome. People have spent thousands of hours on this stuff, right?
Yeah, I mean, I first off, appreciate that note. Again, shout out to the entire Lookout for Vision team, small army between product science, data, UX, engineering. A lot of hours went into this last year, and we're pretty proud and hope customers are realizing how simple this is. To your point, we do want to make this really frictionless for customers to come in, at least train an initial model and see how it works. So we're super excited about this, and hoping customers start to jump on this, and we can work with them really closely to do that.
Yeah, as the resident AI ML ranter on this podcast / show / recurring video series, the real sniff test to me as someone who does a lot of AI ML is that even if I could do this differently and I could be equipped to use SageMaker and Ground Truth to manage all my own, like my data set and all of that, my question to myself is, if I can't find a reason why I would want to do that in a scenario where this solution solves all the same problems because the experience is just so slick, why would I do that? Like, I think there's this myth that it's like when more of it becomes abstracted away from you, you may have trade-offs that you may not be able to tune, or that you may not be able to get what you want. But in reality, if I am anyone that is remotely in the wheelhouse of what you described as a customer, someone that wants to perform visual anomaly detection on objects, and I want to have, separation of projects and stations and all of that, I have my data, it's labeled, I can't think of anything else I want to use, right? Like, I think that there's certainly some opinionated takes here, but I agree with all of them. I think that your data lives in S3. You're managing that from other parts of your pipeline, or you're ingesting it, and so you can just link to where in S3 you want to have. Again, the alternative being there, having to write up your own config file and pair that to all of the images, right? I think that was a super slick experience. And then consequently, on the deployment side, you didn't have to go in and hop over to another services console like EC2 or API Gateway or X-Ray to go see the traces there. You said, hey, if this is your problem, this is your one-stop shop. And I think that, again, end-to-end, you've truly solved a problem much more than just offering a tool to somebody. And obviously there's time and places for tools. There's particular things that you may want to fiddle with, by which a tool is the better choice. But I see this as a real solution. I know in the introduction we said solutions are another type of thing, but this really like it solves a problem and it solves an end-to-end problem, and I don't have to feel like I have to ask a bunch of follow-up questions to understand how I would use it. It really feels like in that short demo, by staying in one console, I there just was no sprawl. It was just very pointed. I was very guided throughout the experience, and I feel really confident being able to do that. And again, I work a lot with AIML. Even Rob, to give that same feedback, goes to show that even folks that aren't knee deep in TensorFlow and PyTorch every day can achieve the business value that they want with AI and ML.
Yeah, it's great. No, thank you guys. I appreciate it. And thanks for having us, right? I mean, we're excited to showcase this, especially fresh after launch. This has been a great opportunity. So I appreciate your time.
Wonderful. Well, we'll let you go in just a few minutes, but before you go, is there anything that you want to say out to the folks in the audience, and anything you want to leave them with, how to get started with Lookout for Vision, or maybe any promotions you can offer them?
Yeah. So, a quick Google search for Amazon Lookout for Vision will take you to our product detail page. A lot of good information, a lot of good documentation on how to get started. We do offer a free tier, so that for the first 3 months, it's 10 training hours and 4 inference hours. So even if you're really curious about how this works, the customer experience, how will this work on a different use case or a completely different data set, A, we want you to experiment. B, we want to hear about how that went, see what we're doing well, where we're not doing well. But we want that feedback. The last one I think I'll call out is we do have a publicly available data set that we released on our GitHub repo. So that is a circuit board data set very similar to what you saw in the demo. There's a whole host of images that we've kind of already organized into training, test, extra images for inference and trial detection. And that could be a real kind of quick and tangible way for you guys to continue experimentation and see what you like and don't like. So that is, I think, the last thing I'll mention. Oh, sorry, one more thing. Partner ecosystem. If you guys, we have a bunch of resources. If there truly is a manufacturer customer out there, or you want to understand what's the right camera specs for me to do this for my customers, we can certainly connect you guys to the right folks to continue that discussion. So I think those would be my quick call outs.
Wonderful. Well, Anand, it's been a real pleasure. Thank you again for the demo. I'm really excited for this. I have some ideas for how I'm going to mess around in the console and try and test this out. But
we're going blueberry muffins, right? Blueberry muffins and chihuahuas.
Blueberry muffins and chihuahuas. Rob and I are going to have an exciting weekend testing that one out. But again, it's been a real pleasure. Hopefully we'll have you back at a later point when you have some more exciting launches, because if this is the start, I can only imagine what's to come. So again, Anand Patel, Senior Program Manager on the Amazon Lookout for Vision team. Thank you again.